Tell me when to start.
I think today the session is little bit early, as we have communicated the message in the morning. That's why many of the participants are still yet to join. Hello.
Hello.
Yes, you are audible, sir.
Okay. You tell me when to start.
Nehal, I
Yes,
think
sir.
how many participants have joined? Now only I think 159.
Yes, sir. We can start, sir.
Shall we start?
Yes, sir.
Yeah, you start from your end, and then I'll introduce Dr. Kulkarni, sir. Okay.
Okay, sir. Okay. Good morning and a very warm welcome all the participants in 1 week online training program on advanced agrometeorological techniques for climate smart agriculture. I would like to invite Dr. Andre sir, organizing secretary of this training program, to introduce today's guest, Dr. J.R. Kulkarni sir, retired scientist from IITM Pune. Andre sir, please.
Good morning, all of you. And Dr. Kulkarni sir, welcome. Once again, you are with us, and you are always with us to guide us for in different programs which we are always organized through this CAST project. I'm happy that once again you are with us. Just for the information of the participants, I'll introduce. I think there is no need to actually introduce Dr. Kulkarni sir. He is a very well-known personality all over the country, and not only in the country but at the global level also. But for the information of the participants, I'll introduce Dr. Kulkarni sir. Dr. Jeevan Prakash Kulkarni. He is the retired scientist from IITM Pune. He has completed his PhD from Pune University and held various posts at national level and acted as advisor for Maharashtra Cloud Seeding Program during the year 2019. Also, advisor Karnataka Cloud Seeding Program 2017. He was the chairman. He is the chairman of India Meteorology Society Pune chapter since 2018 and founder director All India Internet Weather Radio Station 2017 onwards. He is also vice president Center for Citizen Science Pune since 2014. He is the instructor to pilots for aviation meteorology courses since 2014. He is in this job as an expert of the team weather modification research and World Meteorological Organization Geneva. He has worked since 2016. He has also been consultant for various states like Karnataka, Andhra Pradesh, Maharashtra, and member of Hydrology Committee, MMRDA, Mumbai, various other several posts. He is also guiding at national and international level. He has delivered talks, lectures in various universities, even at the global level, like University of Jerusalem, Israel, Asian Institute of Technology, Bangkok, Texas A&M, Corpus Christi, Japan Meteorological Center, Indonesia, Italy, etc. So he has a very wide experience over the at national as well as global level. And his major contributions are establishment of climate and global modeling division in IITM for seasonal prediction of monsoon rainfall using numerical models. He has carried out national experiment on KaiPIC for understanding the role of aerosols in the rainfall process and the efficacy of cloud seeding during 2008 to 2011. He was also associated with the establishment of high altitude cloud physics laboratory at Mahabaleshwar to study the cloud structure. and he has also visited various countries like US, UK, Israel, Thailand, Indonesia, Italy, Japan, Malaysia, Singapore. Mostly half of the globe he has traveled. He has guided 25 MTech students and more than 125 papers, research papers in the internationally recognized journals. He has published his research work with high impact factor. And he is the founder director of NGO Center of Citizen Science, which works for promotion and cultivation of science in the people. Founder director All India Internet Weather Radio Station, and founder and CEO of weather forecasting company Weather Smart Solutions. So with this brief introduction of Dr. Kulkarni sir, I would like to hand over the floor to Dr. Kulkarni sir for his presentation. Thank you, sir, and welcome once again for this training. And always, I hope you will be guiding us in future also. Thank you, sir.
Good morning, everybody. I think I am audible. Thank
Yes,
you,
sir.
Andre sir. Thank you, Sneha, for all the arrangement made for this lecture course. I am happy to be associated with the some program, that is international program. So whatever required from my side, I am happy to share with you. With this, now I start my presentation. Rainfall is very important component of the atmospheric system. That is, not only it is giving the water and other things, but the heat liberated, the latent heat liberated and the condensation has profound impact on the circulation feature. So the clouds are very important, and for forecasting the rainfall, understanding of the cloud and precipitation process in the clouds, they are very important. So with this, I start my presentation, cloud physics and precipitation. Okay. Water is essential commodity for all living things on the earth. It is stored in sea, lakes, and ice covers on the earth.
Excuse me, sir. Sorry for disturbance. Please bring it in presentation mode, sir.
Pardon me, please repeat.
Presentation mode, sir.
Yes. Okay.
Previously it was, sir.
Okay, I'm going.
Yeah. Okay. Yeah. Thank you, sir. Thank you.
Okay.
Yeah, fine, sir.
The water comes to the surface of Earth from the atmosphere in the form of rain, ice, hail, and together it is referred as hydrometeor. The hydrological cycles consist of evaporation of water into atmosphere from sea, lakes, rivers, evapotranspiration from the vegetation, condensation of moisture to form, and development of precipitation in the clouds and return to the ground in the form of rain or snow. This is very well known. This is the hydrological cycle. So this is the evaporation, evapotranspiration, condensation, and precipitation, and return back to the iron surface of Earth. The hydrological cycle, what I have shown, is a dynamic and complex one. Its intensity depends on many parameters like pressure, solar radiation, temperature, winds. It affects the weather and climate system. Climate system and has a complex feedback mechanism. Water stored in the atmosphere in the form of vapor. Cloud can be considered as a engine, atmospheric engine that converts the atmospheric water vapor into precipitation. However, the efficiency of this engine is very low. The word meteor has Greek origin. It means anything which comes from the atmosphere to the earth. And word hydra is related to water. So hydrometeor means anything related to water which is coming from atmosphere to the earth. As per World Meteorological Organization, cloud is defined as hydrometeor consisting of minute particles of liquid water or ice suspended in atmosphere and usually not touching the ground. It may also include larger particles of liquid, ice as well as non-aqueous liquid or solids such as those present in fumes and smoke. Clouds act as most important greenhouse constitution in our atmosphere. They modulate wide range of the processes in the earth. The Intergovernmental Panel on Climate Change, that is IPCC, has defined the role of clouds, and the role of cloud remains leading uncertainty in the anthropogenic climate change prediction. Role of cloud microphysics and cloud radiation, timing and intensity of weather events remains an area of active research. To make headway in reducing the uncertainty in weather and climate prediction, World Meteorological Organization and the IPCC defined a list of essential climate variables requiring global observation. This list includes wide range of cloud properties. So clouds are very important from climate change point of view, weather prediction point of view, and understanding the dynamics of the atmosphere. So this is a new edition of the International Cloud Atlas by World Meteorological Organization. WMO has classified clouds in 10 different types and have been described in this International Cloud Atlas. Cirrus, these have fibrous-like appearance, mostly white in color. They are composed of ice crystal. Their bases are very high above the ground. Cirrocumulus, these look like thin white sheets having small elements or like grain. Ripples composed of ice crystal. And cirrostratus, fibrous, smooth, transparent appearance covering the sky. Vertical growth is moderate. They are composed of ice crystal. These are referred as high clouds. Altocumulus, seen as white, gray patches, layers of rounded masses. They are composed of water droplets. Hydrostratus, gray-brown sheet covering part of the sky. Horizontal extent is hundreds of kilometers. Considerable vertical extent. They are composed of water drops and ice crystals. They are having three distinguishable parts. Ice crystals are in the upper part. In the middle part, mixed ice clouds, crystals, and supercooled water. And lower part is the water drops. It gives continuous rainfall. These are referred as the mid-level clouds. Then there is the stratocumulus. They are gray or whitish looking clouds having patchy appearance with little vertical extent. They are composed of water droplets. At low temperature, they contain ice particles. Cumulus, they are vertically developing clouds. Seen as rising dome. Their bases are dark and nearly horizontal. They are composed of the water drops. Tops extending beyond the freezing level, they have the ice particles. Cumulus, cumulus stratus and stratocumulus are referred as low cloud. Nimbostratus, this cloud occur when there is a slow rising of warm air over extensive horizontal area. Their bases are low. Top extend vertically above the freezing level. They are composed of water droplets, ice crystals, and snowflakes. Their appearance is dark as contain high concentration of drops and large vertical extent preclude the sunlight coming to the earth. They produce continuous rainfall and rarely associated with the lightning activity. So most of the rainfall what we get over the peninsular India is from the nimbostratus cloud, continuous rainfall with light to medium intensity. Cumulonimbus, these are formed when the moisture contain strong upward current. These are associated with hazardous weather, hail, heavy rainfall, strong winds, gusty winds. The tops of clouds spread in the unveiled form. They are composed of water droplets in the lower part and ice particles, hails in the upper part. This is a cloud identification guide by WMO. If it is seen as a vertical growth is there, then it is a cumulus type of cloud. Very annually seen, it is the cumulus nimbus. Then it is cumulus vertical growth is limited cumulus, and then this is the sheet is there, complete sheet is there, then it is your status cloud. This is the cumulus type of cloud, sun is seen. This is altostratus medium cloud. Sun is seen very vaguely. And this is the nimbostratus cloud, very dark cloud giving continuous rainfall. And this is the cirrus cloud. This is cirrostratus, cirrocumulus, and this is the altocumulus. So these are the cloud types. Then the clouds are also categorized in terms of microphysics, cloud microphysics. Cloud microphysics refers to processes of the condensation and rainfall in the cloud. So based on the cloud microphysics, clouds are referred as continental. The clouds which are formed over the land area are called continental clouds. They have strong vertical velocities, that is called updrafts. The concentration of drops, they have a large number of cloud condensation nuclei, that is CCN, and high concentration of small size drops. The cloud Doppler spectrum is narrow. The cloud drops are very high, frequently going above the freezing level. Then there is a marine cloud. The clouds which are formed over sea or oceanic region are called a marine cloud. These are low updrafts and low concentration of cloud drops. There are a large number of bigger size cloud drops and cloud spectrum is wide. So the clouds for land and clouds for ocean, they are different type of cloud microphysics. Then clouds are also classified as warm cloud. The clouds whose tops are below the freezing level are called warm clouds. Freezing level is the height above the ground where the atmospheric temperature becomes 0 degrees Celsius. For the land and Himalayan region in the monsoon season, freezing level occurs at 4 to 5 kilometers above the ground. In the mid-latitude, freezing level is at the ground because surface temperature is 0 or below 0 degrees. So these are called the warm clouds. Cool cloud, the clouds having temperature 0 degrees Celsius. These clouds contain supercool water and ice. And mixed bliss clouds have warm base temperature greater than 0 degrees Celsius, but the tops going above the freezing level. These are the mixed phase clouds. These clouds contain liquid water below the freezing level and supercool water and ice particles above the freezing level. Then there is one class of cloud, that is the orographic clouds. These clouds are formed when the wind impinges on the mountains. The hill slope generates the vertical velocity on the inward side of the mountain and lift the moisture upward to form the cloud. The clouds which are formed over the mountainous region, these are called orographic clouds. Such clouds are seen over the windward side of Western Ghats mountain of west coast of India in monsoon season. The clouds are routinely observed by different methods. These includes visual observation. This is the observation taken by IMD observer in the morning, seeing the sky and identifying the cloud types with his experience and cloud coverage. The sky is divided into 8 parts, and based on the coverage, the cloud cover is defined in octaves, 1 octave to 8 octaves. Ceilometers, this gives the base of the cloud. Sky imager, it is the instrument measuring the action of the cloud cover in the sky at any instant of time. Then satellite and radar are used for the observations of cloud regularly. One of the important satellite which measuring the cloud properties is TRMM, that is Tropical Rainfall Measuring Mission. It is a joint mission between NASA and Japan Aerospace Agency to measure the rainfall in the tropics. The rainfall in the tropics is very important, and tropics covers a larger portion of the oceans, and rainfall over the ocean was not known very accurately. So this mission has been taken up by NASA and Japan Aerospace Agency to measure the rainfall in the tropics. The importance of the rainfall in the tropics is that it is associated with the large amount of latent heat which drives the circulation, not only tropical circulation, but the atmospheric circulation over the globe. So the measurement of rainfall forms very important component. So TRMM is satellite. It flies at a low orbital altitude of 400 kilometers, and TRMM has 5 instruments to measure the cloud properties. These are, one is Precipitation Radar, PR. PR provides the information on intensity of the rain type, cloud depth, height at which the snow melts, then the rain on the tropical area. The operational frequency is 1.2 GHz and spatial resolution is 4.3 kilometers. So every resolution of 4 kilometers it gives the rainfall, and in the vertical at 250 meters. TRMM microwave imager, TMI. TMI gives the information on the water vapor and cloud water and rainfall intensity in the atmosphere. Visible and infrared scanner, that is VIRS, provide information on the infrared and visible radiance in the 5 spectral bands from visible to infrared. Cloud and Earth radiant energy sensor. CS gives the information of cloud properties, that is cloud amount, altitude, thickness, size of the particles. And there is light imaging sensor, LIS, lightning imaging sensor. LIS gives the information on the location of lightning in the tropical region. The lightning associated with the deep convective clouds which contain hails in the cloud. So the LIS gives the information regarding the presence of deep convective clouds, presence of hails. The TRMM has some limitations. TRMM does not get the measurements of the rainfall over mountainous terrain, and it does not resolve the pattern when the ridges and valleys are there. But the TRMM satellite gives the information worldwide in tropical information about the clouds and many of the properties. And there is another satellite called the MODIS. So Moderate Resolution Imaging Spectroradiometer. It is an instrument on board the Terra and Aqua NASA synchronous satellites. Terra has a daytime equatorial cross at 10:30 a.m. local time and Aqua equatorial crossing at 1:30 p.m. night. MODIS gives information of cloud properties like cloud thickness, particle size, liquid water path, and cloud top pressure. CloudSat is another satellite in A-Train constellation of NASA Earth orbiting satellite. It has a cloud profiling radar. TRMM has the precipitation radar, which measures only the precipitation size particle. This CloudSat has cloud profiling radar. It measures the cloud drops with 94 gigahertz frequency. It measures the power backscattered by the cloud drops. It flies at a height of 700 kilometers above the surface of Earth, and period of rotation is approximately 98 minutes. The CloudSat CPR is minimum detectable range as minus 28 dBz. So the reflected power from the cloud drops is measured in terms of reflectivity in the units of dBz. The sun synchronous orbit of the cloud overpasses per day at 1:30 and 10:30 local time. So this is a picture of the A-Train satellite. There are different kinds of instruments and all cannot be put in one satellite. So there are different satellites having different instruments and they are flying very near to each other. So as if there is a one satellite giving the information from all the different instruments. So this is Aura, this another one is Parasol, then the CloudSat, then this is Aqua, and this is a Terra. So all these satellites are in a row very near to each other and giving the information about the clouds, cloud microphysics, lightning activity at a given instant of time as if it is in the one satellite. So this is called A-Train because A is for the afternoon hour. They are crossing the equator in the afternoon hour. Then there is another instrument for measuring the clouds, radar. Radar is acronym for radio detection and ranging. Radar transmits electromagnetic energy in the form of waves in all directions. A fraction of energy is scattered back by the targets, which is received by the receiver. Amount of power received by the receiver gives the information about that is in terms of transmitted power, wavelength, beam width, bandwidth, cross section, and physical characteristics of objects like raindrop, ice, and hail. Amount of power received gives the intensity, location, and vertical extent of the cloud and the rainfall. Then what is a Doppler radar? When the source of the signal and observer, they are in relative motion, there is a change in frequency observed by the observer. In case source is and observer are moving closer, then frequency is increased and vice versa. When the source and observer, they are moving away from each other, the frequency decreases. The Doppler radars compare the transmitted frequency and received frequency and compute the change in frequency. Difference in the frequency is proportional to the velocity of target. Radars having this capability are called a Doppler weather radar. Then electromagnetic energy transmitted by radar is in the form of electric and magnetic fields, and which are perpendicular to each other. Orientation of this field is called polarization. The radar which emits electronic wave pulse in these two horizontal and vertical fields, it is called horizontal and polarized. This is called a dual polarization radar. These radars give accurate information about the type of hydrometeor. When hails are there or ice particles are there, sometimes they are flat, sometimes they are three-dimensional structure. So these two waves, polarized radar gives the accurate information about the size of the cloud drops, size of the ice particles, held particles in the cloud. So the dual polarized Doppler radar are the state of radars used for the measuring the cloud properties. This is the one typical picture of today morning by Mumbai radar. So these circles, they give the radius. This is the center of the radar, and from there, this is 50 kilometers radius circle, 100, 150, 200, and 250 kilometers. And this color shows the reflectivity, and here is the color code for the dBz. So 20 dBz, all these are clouds with the 20 dBz reflectivity. Embedded in this one, there are clouds which are having the white color where the reflected is 20 more than 30 dBz. So there are some clouds, cloud patches, isolated cloud having the reflectivity 30 dBz. Now this scales give the height of the cloud in terms of kilometers 3, 6, 9, 12, 15 and 18. So all the clouds 3, 6 up to 9. So cloud tops here are going up to the 9 kilometer, but the higher reflectivity resides in the lower part of the cloud from 3 kilometer to up to 6 kilometer. So this gives the information of cloud cover at any instant of time, and radar, this is called a volume scanning radar. It scans the volume in three-dimensional within 10 minutes. So every 10 minutes we can give the picture of the distribution of cloud, their vertical extent and reflectivity, that is the amount of liquid water or ice particles contained in the cloud. Then based on that and empirical relations, the rainfall at the ground is estimated, that is based on the one empirical formula, that is Marshall-Palmer relationship. So we get the information about the rainfall at the ground at within a 10-minute interval. So these are the advantages of the radar. This is a satellite picture of today morning. You can see this, the satellite observes in a horizontal scale and the radar observes the cloud in the vertical section of the clouds. So this picture. Satellite observes clouds in different bands. These are the infrared band, visible band, shortwave infrared, midwave infrared. So in infrared band, the clouds are observed by the radiation radiating from the cloud top and cloud surfaces. So every body emits radiation based on its temperature. The more the temperature, more the radiation. Less the temperature, less is the radiation. So this shows the cloud cover over the Indian region. This is the India and cloud cover. The clouds are extending over most of the Indian region over the sea area. So these pictures are available for every 30 minutes on the internet by different satellites. We have INSAT satellite, INSAT 3D. We have another satellite, the international satellite Meteosat also give the information of the clouds over the region. The different channels of the satellite. They are for identifying the deep clouds, high clouds, low clouds, and the low level snow cover in the region. If you see, the rainfall distribution is very inhomogeneous over the country. There are regions of very high rainfall, like the Konkan area, northeast area, where the seasonal rainfall is more than 200 and 250 centimeters. But there are areas for the peninsular India, like some of the subdivisions, the rainfall is hardly 50 centimeters in the season. These are called the rain shadow subdivisions. I have given some example how low rainfall is there over the subdivisions of Maharashtra, Telangana and Karnataka. So rainfall is about 122 millimeters in June, July, August, September. The rainfall distribution is also different in the month-wise. For all India, the rainfall is highest in month of July and August. They contribute about 35% of the seasonal rainfall. The total rainfall in July and August is 70%, and June and September contribute only 30%. But the distribution is very different over the rain shadow area, where the rainfall is maximum over the July, August. Bimodal distribution is there, and August rainfall is usually low. So this happens. The purpose of showing this slide is that the rainfall distribution is widely different in spatial case and in temporal scale also over different parts of the country. Now coming to the rainfall process, very important thing is the aerosols. Aerosols play important role in the precipitation process. Aerosols are, they are referred to suspended solid or liquid particle in the atmosphere. Atmosphere contains a large concentration of aerosols. Presence of aerosols is essential for formation of clouds because they act as a cloud condensation nuclei and ice nuclei. Water vapor is there in the atmosphere, but some material is required on which the water vapor to condense. So these aerosols, they act as the material for formation of the cloud drops. The size of aerosols span from few nanometers to 100 micrometers. The upper limit of size distribution of the aerosols is 100 millimeters because the aerosols of the higher size, they come down with gravity to the surface of Earth. Lower limit is few nanometers or the size of the molecular crystal. So aerosols have different categories. They are categorized in different ways. Nuclear mode aerosols in this mode have last in the size range 0.005 to 0.1 micrometer. This mode contains highest number of aerosol particles. Lower end of this mode is termed as ultrafine particles. The aerosols in this range are generated by photochemical reaction of the gases in the atmosphere. For the combustion, they show rapid appearance and increase and decrease in the morning hour. So nuclear mode aerosols are large in concentration in the atmosphere. Then there is accumulation mode. The size range is 0.1 to 2 micron. There are two peaks in this one. These are called the condensation nuclei and the combustion nuclei. The combustion of fossil fuels produce these particles, combustion of sulfur, nitrogen, and organic compounds in this mode. They produce these aerosols of accumulation mode. The small size particles coagulate to form the aerosols of condensation mode. The coagulation decreases with the height. Then there is coarse mode aerosol. These aerosols are in the size range more than 2 microns. Now condensation. The first stage of the process is the condensation. Condensation is change of water vapor to liquid state in contact with cloud condensation nuclei. Cloud drops are formed on the atmospheric aerosols in the condensation process. This process is called heterogeneous nucleation because it requires some embryo for formation of the cloud drop. If the moisture or water is condensed without any embryo or particle, it is called a homogeneous nucleation. But homogeneous nucleation, the temperature requires to be very, very low, minus 40 degrees Celsius. In the atmosphere, the temperatures are in the range 20 degrees Celsius to about minus 10 degrees Celsius. So most of the nucleation is heterogeneous nucleation and they require some embryo to form the cloud condensation. So cloud condensation occurs when the actual partial pressure of water vapor is greater than the saturation vapor pressure at that temperature and atmosphere. So when the partial pressure of water vapor is greater, then the condensation occurs. But the cloud-based condensation of available moisture is not instantaneous. Actual water vapor pressure is, or water vapor partial pressure is higher than the saturation vapor pressure, leading to the condition of supersaturation. So supersaturation is very important. Kohler described how the cloud droplets grow with different diameters of the aerosol particles of different supersaturation. So this is a diagram, Kohler diagram of the condensation with respect to water vapor supersaturation and droplet diameter. So if the droplet diameter is very, very small, the supersaturation required is very, very high. That is on the, if you see, the viscous goes above and requires very high supersaturation. As the droplet size increases, then the supersaturation required for condensation decreases. It attains maximum value at 0.4 supersaturation and then automatically it increases in the drop size. Similarly, as the droplet diameter increases, the supersaturation required is very, very low. So the most important point is the size of the cloud drop, and most of the particles, they have the ammonia sulfate particles which require the very low supersaturation. So this curve is called 0.05 micron diameter, 0.1 micron and 0.5 micron diameter. There are two processes acting on the droplet. One is the surface tension effect that increases the supersaturation, and solute effect, that is impurities in the drop, that is the aerosol concentration, that decreases the supersaturation required for the condensation to occur. The subset of atmospheric aerosol, all the aerosols are not acting for the condensation nuclei. There is a small component of it. The subset of atmospheric aerosols serves as embryo upon which water vapor condensates and grows under supersaturation existing in the cloud as per Kohler's theory. These particles are called CCN, that is cloud condensation nuclei. At any given location, CCN vary by several orders of magnitude with time, depending on the proximity of sources, wind direction, air mass type, and precipitation. Near the Earth's surface over the land, there is a large concentration of CCN than over the ocean. The rate of production of CCN from burning vegetable matter is of the order of 10 raised to 12 to 10 raised to 15 per gram of material. So a huge amount of CCNs are produced through the burning of vegetables or vegetable matter. Forest fires are a large source of CCN. Over the ocean, sea salt particles enter the atmosphere through process of wave breaking. They are having a large sizes and hence they are called as giant CCN. Most CCN consist of sulfate particles. For the ocean's organic sulfur in the form of gases, dimethyl sulfide, DMS, or methane sulfuric acid, MSA are the sources of CCN. The concentration of cloud droplet is equal to the concentration of CCl activated by peak supersaturation. So SS is maximum at 100 meters above the cloud base. Above it decreases. So number of cloud droplets formed in the cloud is directly proportional to the concentration of CCN. Those are activated by supersaturation. And supersaturation is maximum at 100 meters above the cloud base. Above it decreases. Now the very important process is the rate of growth of droplet. Once a droplet is formed by condensation, then its growth depends on the size of the droplet. The rate of growth of droplet by condensation decreases with increase of radius of the droplet. So smaller is the droplet radius, the growth rate is smaller, and if the radius is more, growth rate is more. Smaller droplets grow faster. The smaller droplets grow faster and large droplet growth slows down. The size distribution of cloud droplets becomes narrow with time. This is called monodisperse distribution. So the small droplets, they grow. Large droplets, they don't grow much. So the size distribution becomes narrow. That is called monodisperse distribution. Raindrops have radii of orders of millimeter. So raindrops, the size is millimeter and the cloud drop is in the micrometer. So the growth of condensation in the clouds is too slow to produce raindrop. So for formation of raindrop of 10 micrometer to grow 1 millimeter cloud drop requires an increase in volume of 1 million times. So that is the amount of volume required for forming a single raindrop of 1 millimeter size. And the condensation process is not efficient to form the cloud drop or raindrop. Then there is ice nuclei. This is the cloud condensation nuclei for formation of drops. And formation of the ice particles, ice nuclei are required. So ice formation can occur in two ways: homogeneous nucleation, which occurs when the vapor is converted into ice particles, or freezing of cloud droplet. For such homogeneous nucleation to occur, very high supersaturation and very low temperature of the order of minus 40 degrees are required. Such conditions are not observed in the troposphere. Except in the cirrus cloud, there are no aerosol particles or ion nuclei. The homogeneous nucleation occurs, but those clouds are very high in the atmosphere. Heterogeneous nucleation occurs when the ice particles are formed on the aerosol particles which have ice-like structure. These are called the freezing nuclei. The freezing nuclei are two types, that is deposition and condensation. Aerosol particles on which ice is formed directly from vapor phase are called the deposition nuclei. If the aerosol particle is contained within the droplet, these nuclei are called the immersion freezing nuclei. So the actual mechanism of rain formation in the clouds is other than the condensation, that is called a collision coalescence. Mechanism which operates to grow the cloud droplets is called the collision coalescence mechanism. So initial cloud droplet distribution show a monodisperse distribution having mode at 10 to to 15 microns. So cloud drops by condensation, they grow up to 10 micron size. And beyond that, they don't grow. Due to the turbulence in the cloud, the droplets are under constant motion. So cloud abrupt velocities are there, and the cloud atmosphere is very turbulent. So in that turbulent motion, probability of colliding small drops on one another is, if the turbulence is not there, then the probability of the collision is very small. This is state is referred as colloidal stable condition. If the spectrum of cloud, in the spectrum of cloud, there are few large drops of radius more than 20 micron. If a few drops are there, the cross-section of these drops are larger. The probability of collision of these larger droplets or the other small droplet is very high. This is referred as increase in collision efficiency. So if few drops of larger size are there, they have larger probability of colliding with smaller drop, that is called the collision efficiency. The bigger droplets collect the smaller droplets on its way. This droplet is called the collector droplet. Small droplets get absorbed. The small droplet get absorbed into large droplet. Thus the large droplet grow to millimeter size. This process is called collision coalescence process. The size range from 12 to 20 micron radius is considered as threshold radius for initiation of rainfall process in the cloud. This process occurs in the warm cloud. So minimum size of the cloud drops to start the collision coalescence process is 10 to 20 microns. If the drops are having radius less than 12 micron, the collision process is not initiated. This is a sketch of how the collision process works. These are the cloud drops, small cloud drop, and there are few large cloud drops. Okay. So large cloud drop, they are coming to the earth because of gravity, and in the process they collide with the small drops, and some of the drops they escape, but some are joined together and the cloud drop size increases with the collection of these drops and it becomes still higher. This is called the collision and coalescence joining together process. If there are n number of cloud drops in a unit volume, having radii Ri is different for each of the cloud drop, and there are n droplets. The total liquid volume contained Q per unit volume is the sum of volumes of all the drops. So Q is equal to 4/3 pi summation from I is equal to 1 to n Ri cube Ni. Ri cube is the volume, 4 pi Rs cube, that is the volume of the sphere. So, and Ni is the number of cloud drops. So this is the total liquid water contained in the cloud drops. Now if we have the mean radius, the mean value of droplet radius taken as RV, then the same equation we can write is Q is total volume of the liquid is 4/3 pi RV cube. More the number of drops in unit volume, the lower is the mean volume radius. Lower the radius, lower is the collision coalescence efficiency, and lower the rainfall. So if there are a large number of aerosols, number of CCN, and hence the number of cloud droplets will be larger, there will be a few cloud drops of having required minimum threshold of 10, 12 to 20 micron. The rainfall process in these clouds will be slow, producing low rainfall. So many times we see the clouds, but they are not giving the rainfall. That is because they contain large number of the CCN, large number of cloud drops, and there is a competition for available moisture. And because of this, the cloud drops do not grow in the size beyond the threshold value of 10 to 20 micron, and they do not grow to the millimeter size giving the rainfall. So many times the clouds are seen, but they are not giving the rainfall. Then there is another process of the uh, increasing the precipitation that is called the Langmuir chain reaction. The important aspect of this collision collation process is Langmuir chain process. As the raindrop grow due this process, they become unstable. They start breaking up. The breaking probability is high when the raindrop becomes higher than the 6 millimeter in the size. So when raindrop becomes very large in size, they break up. So each fragmented raindrop accelerates the collision collation process to produce the larger raindrop. This process accelerates the rain process in the cloud rapidly. This process is called Langmuir chain reaction. One big drop, raindrop produces a number of small drops, and each small drop grows to a bigger size to produce more small drops. So this is not only the collision collation process, but the Langmuir chain reaction is very important for accelerating rainfall process in the clouds. There is another process called the Bergeron process above the freezing level. So above the freezing level, the mixed phase clouds, they have the supercooled water with ice particles. Some of the supercooled water is converted into ice, so supercooled water coexists with ice particle. Saturation pressure over ice is less than over the water. The plane surface of water, the saturation pressure is higher. So therefore, the water evaporates and moisture gets deposited on ice particle. In this process, ice particles grow in size. This becomes, when the ice particles become heavy and start falling down, on their downward journey, these ice particles collect small ice particles and cloud water drops to increase in size and weight. After coming from the base of the cloud, these melt due to higher atmospheric temperature and come down to the surface of Earth in the form of rainfall. If the atmospheric temperature is below 0°C, then this come to the surface of Earth as ice particle. This process of precipitation formation is termed as the Bergeron process. So there are two processes. In the warm cloud, it is the collision collation process helped by the Langmuir chain reaction, and in the cold clouds, it is the Bergeron process. This is the sketch of the Bergeron process. So this is in the mixed phase region. Water drops are there and small ice particles are there. And this is the water molecules. So cloud drops are which are in the supercooled state. That means temperature is below the 0°C. Then this cloud drop they evaporate and moisture is deposited on the ice crystals, and the ice crystals grow in the size. The ice crystals ultimately the cloud drop sorry they evaporate and ice crystals grow in the size. This is the process by which the rainfall occurs in the cold clouds. Now the convective clouds, what we see, they transform approximately 10% of water vapor into precipitation that reaches the Earth's surface. So water vapor in the clouds enter the clouds from the base of cloud, which is converted into cloud water. So mass of water entering the cloud from the base can be calculated using the mixing ratio and density of air at the cloud base. So we can calculate how much water vapor entered in the clouds and how much it is converted into the raindrops and the rainfall. So we can calculate the efficiency of the cloud, and efficiency of the cloud is very low, 10 to 20%. So only 20% of the moisture which is enter in the cloud is converted into the rainfall. So clouds are low efficiency engine. So in that, sometimes we see the clouds. So cloud seeding is used to enhance the efficiency of the cloud. So scientific basis of the cloud seeding. There are two ways of doing the cloud seeding. One is the hygroscopic seeding, which is carried out the base of the young convective clouds in the out-of region. Seeding particles are classified into three classes. These are large diameter of 1 micrometer, giant diameter between 1 to 10 micrometer, and ultra-giant diameter, ultra-giant particles of diameter more than 10 micrometer. Seeding of large particles enhance the cloud efficiency through the competition effect. When the large hygroscopic particles are seeded, they are having the affinity of the moisture. So there is a competition of collecting cloud moisture between the large cloud seeded particle and existing smaller diameter particle. Being hygroscopic in nature, the seeded large particle absorb more water at the cloud base, which reduces the supersaturation at cloud base. The cloud droplets of low sizes evaporate, resulting into reduction of the cloud droplet concentration and broadening the cloud drop size distribution at the cloud base. More number of large cloud droplets enhance the collision process, resulting into enhancement in the cloud efficiency. So when the seeding is done, it enhances the efficiency of the cloud in converting the cloud moisture into the cloud drops and rainfall. There is another way of doing the cloud seeding is the ice nuclei or glacial seeding. So ice nuclei concentration is very, very low in the atmosphere. So glacial seeding is used to enhance the ice nuclei in the supercooled and mixed phase clouds. It helps to increase the ice particle concentration in the supercooled region of the cloud. Some of the materials which act as ice nuclei are dry ice, silver iodide, and liquid nitrogen. Among these, dry ice and silver iodide are widely used in seeding programs in the world. So understanding the cloud microphysics rainfall process helps to increase the efficiency of the cloud in giving the rainfall through various methods of the cloud seeding, hygroscopic seeding, or the glaciogenic seeding. This ends my presentation. Thank you. Questions are welcome. I hope I have not taken much time.
Yes, sir. Yeah, sure, sir.
Oh, I have taken more than 1 hour. But I am.
Thank you, sir, for your nice presentations.
Questions?
Yes, sir. Yes, sir.
Yes.
I request all the participants, if you have any questions, please ask in chat box or either raise your hand. Yeah, sir, first question from Anil Patel. How octascale can measure cloud coverage?
Yeah. Is a unit of measuring the cloud coverage. The whole sky is divided into 8 parts. Okay? That is manually. There is no instrument for this one. And seeing how much part of the covered, that one is measured in terms of the octa. 3 octa means 3 parts out of 8 is covered by clouds. 4 octa, half the sky is covered by clouds. Like that, these are 4 octas. And if the sky is overcast, covering all the parts of cloud, it is said that 8 octaves. So 8 octaves is the maximum, and 1 octave is the lowest.
Yeah, thank you, sir. Next question from Yeah, from Devashish Jena, what is the effect of cloud cover over the plant temperature and its growth?
Yes, this is very important. Cloud acts as the greenhouse gas effects. When the cloud cover is there, then solar radiation going from Earth's surface is transferred back to the surface, so temperature is increased, ground temperature is increased. If cloudless, then the radiation cooling is there, temperature of the Earth's surface goes down. So there is a strong diurnal variation over the surface when there are no clouds, like a desert region. Maximum temperatures are very high because incoming solar radiation is very high and outgoing long variation also very high. As against when there is a cloud cover, the diurnal variation is also small and minimum temperature is not going below the value.
Thank you, sir. Nice information. Actually, it's also part of general knowledge also. Next question from Manimala. What is the difference between cloud particles and water particles and ice crystal particles?
Yes, yes. Okay. So when the condensation occurs over a condensation nuclei, that is what we call it cloud droplet. Okay. Cloud droplet is having the size in the range of microns, 10 to 12 microns. Okay. And the raindrop is of the size of millimeter or 0.1 millimeter. So 100 or 1,000 times bigger than this. So this is called the raindrop. And then we have more the raindrop, we have the water particles. Okay. So that is the scale of this. Ice particle, when the water condenses on the ice nuclei, the ice is formed. So that is called the ice particle. Ice particles of different sizes, that is graupel is there, snow is there. Different types of ice particles are there depending on the temperature and depending on the formation process. They are columns, they are flat surfaces. So if you see different types of ice particles that coexist, and hail is also ice particle. So it's bigger in size, sometimes like a tennis ball. Okay.
Yeah, thank you, sir. Next question from Abhishek Mishra. Is artificial cloud making is beneficial to crops?
Yes, artificial cloud seeding has been done for more than 50 years, and the crops, they require the water or the
So you are not audible, sir. Hello. Hello. Kulkarni, sir, you are not audible, sir. Yeah, participant, sorry for inconveniency. Expert got disconnected due to some technical reason. We are solving it. We will back. Please stay with us. Yeah, expert has joined and they will share their screen within 1 minute.
Hello. Yes.
Yes, yeah, Kulkarni sir, yeah.
Okay, okay, okay.
Yes,
You are able to hear me now.
yes, yes, sir, yes.
Okay, okay. The question was about lightning.
Yes, sir, yes.
So, in the cloud, when the cloud tops go above the freezing level that is the 0 degrees Celsius, the water condenses into ice particles. These ice particles, they are having the upward and downward movement because of the turbulence in the cloud. So Earth is negatively charged, that everyone knows. So the particles are polarized with the positive charge bottom and negative charge upward because of this induced charge in this one. So all the particles, they are polarized in this way, positive charge at the bottom and negative charge up there. Then there is a movement of these ice particles within the cloud. The top particles, they collide on the small particles. Top particles having the positive charge on the bottom and small particle having the negative charge at the top. They cancel each other. So the large particle, they come down with and have the negative charge, and the small particle, they ice particle, they go up, they have the positive charge. So in this way, there is a separation of the charged particles in the clouds. So negative charge at the base of the cloud and positive charge at the top of the cloud. Then there is a potential gradient developed, which breaks down if it increases beyond certain limit, and there is a lightning within the cloud. This is called intra-cloud lightning, icy lightning. Now, when the negative charge at the base of the cloud, they induce positive charge at the surface of Earth, and there is a from cloud base negative charge to the positive charge at the surface of Earth. That is called the cloud to ground lightning. So this is CG lightning. So these two types of lightning strokes are occurring. And as I told you, there is a instrument in the satellite LIS, light detecting instrument, that measures the location of the lightning for different parts of the globe, and that information is available at any instant of time. I am there on the IMD website. When the lightning occurs, it emits the radio frequency waves, and based on that radio frequency wave, the lightning is detected by the instrument. So instrument detects the lightning based on the radiation, radio frequency waves emitted by the lightning stroke. So that way we get the information about the lightning. So next.
Yeah. Thank you, sir. I'm taking two maximum two questions, sir, because we have international webinar. Sorry, national webinar delivered by Mr. Kulkarni on AM. So this next question from Arivu Kumar. Doppler radar is used for weather forecasting or it is used for only measuring the rainfall?
Yes. Doppler radar is important instrument for measuring the cloud particles, cloud droplet distribution, and the winds. Most importantly, winds, because has the Doppler facility. So winds, if you know the winds, if you know all the cloud structure, these are used as the input data to weather models, and weather models can accurately predict the rainfall process. So it has more utility than simply the location of the clouds, of the prediction of the rainfall.
Thank you, sir.
Okay.
Next question, whether the India has been took part in a international cloud seeding program.
Can you repeat it?
Just yes, sir. Is India involved in international cloud seeding program?
Is?
India.
Yes, yes,
Involved.
yes. Yes. In India, cloud seeding programs are done by different states, Karnataka, Maharashtra, and Andhra Pradesh. They did in the past. We have long history of the cloud seeding right from 1950 onward. We have also research program called the Cloud Aerosol International Interaction and Precipitation Enhancement Program by IITM for 5 years program, in which the understanding of the cloud processes has been done with the measurements of cloud microphysical parameters with the instrumented aircraft. And there are many programs, long history of cloud seeding in India for last more than 50 to 60 years.
Thank you, sir. Next question from H.Y. Patil, US Dharwad. How the cloud seeding occurs, and after cloud seeding, how much time took for raining?
Yes. So when I told two types of cloud seeding, glaciogenic as well as hygroscopic. So when the seeding is done, the seeded material accelerates the precipitation process in the cloud. It requires around 20 to 30 minutes, and after 30 minutes the rainfall starts, and it stays there for or extends for 4-hour period. So when the rainfall process is activated, it continues for 3 to 4 hours depending on the size of the cloud, type of the cloud, and extent of the cloud. But on the average, it requires 20 to 30 minutes to initiate the rainfall process, and on the average, it extends for 3 hours.
Okay, thank you, sir. Hope Patil sir got the answer of the question. Next, sir, a question from Devashish Jaina. It is very important, I think, nowadays. What is the effect of COVID situation? Less pollution, that is less aerosols. Is there any impact of this situation in cloud formation or rain in a nowadays situation?
Yes. So aerosol, more the aerosols, there will be more cloud droplets and more competition for existing moisture. So the growth process is arrested in such way. If the aerosols are low in concentration, that happens over the oceanic region. The rainfall process is very activated, very efficient, and gives very good rainfall. So aerosols, if aerosols are there, they are favorable for the rainfall activity. But aerosol should be of particular type. Any aerosols will not act as the CCM for the clouds.
Okay, thank you, sir. Due to time limitations, we have to close this session. Actually, we at 11 a.m. we have that national webinar on biofuels. So, sir, there are so many questions in chat box actually. So I have taken representative of all those questions, sir. Uh, uh, Now, all the participant, we will what we will do. We will save this chat box, and later on, sir, we will mail this all the question to you, sir.
Yes, that will be fine.
Yeah. Yes, sir.
Pleasure to answer all questions.
Yes, sir. Yeah, sure, sir. Thank you, sir, for being with us. And sir, please be at in that
Welcome.
session of webinar. Biofuel, sir.
Welcome.
Yeah, yes, sir. Yes, sir. Yes, sir. Andre, sir, are you there, sir? Might be okay. On the behalf of Center for Advanced Agriculture Science, Tech and Technology and all the participants, faculties, academicians, scientists, KVK staff, SMS, program coordinators, all the industry persons, and from persons from NGO, and on behalf of all the students, uh, I am very much thankful to Mr. Dr. Kulkarni sir for delivering a very nice talk on that cloud. Sir, thank you so much, sir. Once again, sir. Kulkarni sir. Yeah.
You're welcome.
Yes, sir. Thank you. And sir, shall we close this session now? Hello, Kulkarni sir.
I'm listening.
Yes, sir. Shall we close, sir?
Yes, yes, yes.
Yes, sir. And I request all the participants, please present at this webinar, which is to be going to start at 11 a.m. today. So I have shared this screen on that flyer, so you can find every detail on this flyer. So I request all the participants and all the experts of this training program. Sir Kulkarni sir, once again I request you to please join this webinar. It's very nice actually. And all the participants to please join this webinar, and which is to be held at 11 a.m. So you can join by this clicking YouTube link or Facebook page. You can directly visit Facebook page of Mr. Nitin Gadkari ji, Honorable Minister, and you can also watch that live streaming at our YouTube or Facebook page of CAST. So thank you one and all for being with us. Thank you once again.
Thank you.